Are you recording this whole thing?
Yep.
Out of the percents, one's going to be mass, one's going to be based off of volume. But what you need to know is that 1 gram is also equal to 1 milliliter. You need to write it down. 1 gram is equal to 1 milliliter.
See, I just wrote it down.
Yes, it does. So, mass percent and volume percent. Solute is the thing that is being dissolved. It is the salt. The salt. That's the solute. What are we going to do to the salt?
Dissolve it.
We're going to dissolve it in what is water? The water is the solvent. It is the universal solvent. So once I put in our water here, so I'm going to try to dissolve this in, right?
That might take a while.
I know. No. So water is your solvent. The solute was the thing going to be dissolved, and once I put them together, we have a
solution.
What you have to pay attention to so that you do not miss points. Solute is always divided by solution. They will probably give you the solute and the solvent. You will have to add them together to put them on the bottom into solution. If the problem directly states solution, you're good. You don't need to add them together. You just put it on the bottom, divide, multiply by 100, you get your percentage. So mass will have to be gram over gram, or kilogram over kilogram. Volume will need to be a liter or milliliter over a liter and milliliter. So they've got to be the same units. You may have to convert one to the other. The unit to do that is 1 milliliter is also equal to 1 gram. Now we've got 2 other ones. Molarity and molality. Molarity is the mole of solute per liter. Again, your triangle is coming back. If you don't know how to use this one, we're in big doo-doo. They're going to give you grams. You have to find moles. You use that moles and you plug it in at the top. It is the same for molarity and molality. Mole and mole. The difference is the bottom portion of what you're going to divide by. For molarity, it is a liter, and it must always be liter. So if they give you milliliter, you're going to have to convert it. Molality is mole per kilogram, and then you just convert if they give you gram. So they may give you gram and gram. 1 gram goes to moles. That's the one that's being dissolved, the solute. The other one's your solvent, that's your kilogram, goes on the bottom. All right? I'm going to erase that. Let's just use liters of other, or liters of solvent. Now, mole, molarity, molality. Notice this one, I left it as a capital M. This one is a lowercase m. Those are your labels. Molarity is labeled in a big M. Molality has a little m. It is just like that on your cheat sheet as well. If you look on your cheat sheet, the back side in the boxes of where to solve for these. Molarity has a capital M for a reason, and molality has a little m for a reason. Mole fraction, for some reason, students do not like mole fraction, but it's actually very easy. Mole fraction, you have a part of mole divided by total mole.
Then again, you are the teacher.
What does that sound like? You have a part divided by a whole. The only thing that's missing is you are not multiplied by 100. Mole fraction must be left in decimal, and they will always be less than 1.
Oh, you get that?
If you get a number that is higher than 1, you did something wrong.
You're good.
Okay? The issue here is they're going to give it to you in percent. We need this in moles. What do we need to know to get to moles?
Molar mass or gram.
We always do this.
Grams.
The grams. What can we do to percent for gram? What did we do with empirical formula? We dropped the percent and we replaced it with a gram. We can do the same thing for mole fraction. As soon as you see it says mole fraction, they give you a percent, drop the percent, make it into a gram, because we always assume then percentage is out of 100, so it's a 100 gram sample. So I can take it as a 30%, then it's 30 grams. That would be one item. You also have to find the moles of the other item that's also involved. This is total. You add them together. So you're going to have a piece over the total. So you have to find both pieces, put them into moles, and get their total. That's what goes on the bottom, just like a percentage.
But if it's a percentage, don't they always add up to 100?
They do, but you're going to have different mole fractions.
Okay.
Okay?
Oh, not
You
really,
can't
because of
just take a
rounding.
percent and get your number. It doesn't work. All right.
So much more sense now.
Henry's law. Henry's law, S here is solubility. How well things are being dissolved. Solubility.
That's not being dissolved very
Okay?
well.
No, I need more water. This would be a supersaturated solution.
Yeah.
There's way more salt that can actually be absorbed in the water. This is supersaturated. Okay? What's the other two types?
Unsaturated.
Unsaturated, too few, saturated, perfect. That's what you used yesterday in your lab with the pipette of the salt water, and you did it on the hot plate. That was a saturated solution. This one's super.
So wait,
Henry's law. Your
what
solubility
was the saturated?
depends on your pressure. Solubility is always labeled
Well, let's hope you're
gram
not having super saturated
per
fats.
liter. So if it says so many grams per 1 liter, you're good. But what if it said 5 grams
Or 2
in
liters.
2 liters?
You divide 5 by 2.
You have to put the 2, so then that would be your 2.5 gram per liter that would then go in the problem. All right? Then your pressures, just make sure both pressures are in the same one. Biggest thing is, Henry's law, for this entire chapter, this is the only equation that has pressure in it. So if you have a problem that has pressure, you have to use this one.
Definitely
There's no
believe
other choice, there's nothing else you can do. You just use Henry's law as soon as you see a pressure value. And that's it.
That's good.
It is the only one. So if you see pressure, don't go back and use chapter 12 and 13. Don't use any of those. Do not use the combined law or anything. You just have to use your solubility divided by pressure. It's the only one. Now diluting. Diluting means you're going to start with a stock solution, something that has a higher concentration, and you want to add water to it. You did this in your lab 2 days ago. You added water and you diluted it. You could have diluted it this much, or you could have diluted it even more, right? So this could be your stock solution, what you're starting off with. So how much of this do I need to get myself to here? How many milliliters? How many liters? You plug it into your equation for the diluting. Now it'll be M1, V1, or it could say M stock, V stock. M2, V2 could be your product side, how much you really want. Most of the time, you're going to know this side, and you're solving for one of these two. And I'll say most often you're going to find out how much volume you need of it. As long as your labels are the same on both, you do not need to convert anything from one thing to the other. So your milliliter is just fine. A liter and a liter is just fine. So this is everything that you should know by now.
Not really. That's everything we just learned today.
Okay, but it's easy. It really is easy. All you have to do is just plug it in. All of these are on your cheat sheet except the top two because they're percentages. All the rest of these are on your cheat sheet on the back side. All right?
Yay.
Tomorrow we have 2 more equations to learn.